Hi, my name is Arisa Shaira binti Azmi and I will be one of the presenter for today.
And I am Nur Akila Shaira binti Zahiri, also a presenter for this group.
And before we begin, these are the content that will be included in our presentation today, which is first, introduction, thermodynamic analysis, sustainability evolution, engineering solution, technical and value-based consideration, and conclusion.
Introduction. What is an industrial boiler? Industrial boiler is used in factories to generate steam or hot water for production processes. They are widely used in chemical, food processing, power generation, and manufacturing industries. The main sustainability issues in industrial boilers is energy waste. Large amounts of heat are released into the environment instead of being reused. This causes higher fuel consumption and increased emission. To improve sustainability, industries can install heat recovery systems such as economizer and heat exchangers. These technologies recover wasted heat and improve overall energy efficiency.
Continue on with the thermodynamic analysis. First, we got the first law of thermodynamic, which means energy can be neither created nor destroyed. It can only change form, which in this case, dot energy in equal to dot energy out. Next are the general energy balance equation, which delta E system equal to E in minus E out. And these are the example of the visualized image of the system. Continue on based on our analysis also, these are the sample of diagram for energy flow and major losses in industrial boiler system, which as you can see is a high pressure steam used as for processing, and its major energy loss came from the flue gas stack loss. This typically account for 10% to 20% of total energy input, carrying a sensible heat and latent heat from water vapor generated during combustion right out of stack, and its minor losses are from radiation and convection losses from the boiler shell and blow down losses, removing hot water to prevent minor build-up. And
So now sustainability evolution for environmental impact. Energy waste. Waste heat released into the atmosphere, valuable energy not utilized effectively. Next, for air emission, increased carbon dioxide emissions from excessive fuel usage, which will be contribute to global warming. And resource consumption. More fossil fuels are required and faster depletion of natural resources. So now I'm going to talk about potential improvement for sustainability. For heat recovery system, we can install economizer, use heat exchanger, or recover waste heat from exhaust gases. And we can also improve insulation, like reduce heat loss from boiler surfaces. But I think we can use regular maintenance too, like maintain optimal combustion efficiency, and lastly, energy monitoring system, which we can track energy usage and identify inefficiencies.
carry on to our engineering solution, we suggested to do an installing of an economizer. This is to recover the significant energy loss through the exhaust stack. Structurally, this is a specialized gas to liquid heat exchanger consisting of bundle of high surface area fine tube positioned directly in the path of the existing flue gas stream. The cold boiler feed water is rerouted to flow inside the tubes, while the hot exhaust gas passes over the outside of the tubes in counterflow arrangement before escaping into the atmosphere. And how the thermodynamic principles support the solution is by first enhance the heat transfer. The economizer utilizes the temperature gradient between the hot existing flue gas and the cold incoming boiler feed water. Heat naturally transfer from the gas to the liquid across the tube. Next are the enthalpy elevation. By extracting this waste heat, the economizer preheats the incoming feed water. This raises its starting enthalpy before it ever touches the boiler burner load. Last but not least, the efficiency gain. Because the water entered the boiler shell at much higher temperature, less fluid heat input is required to boil into the steam. This directly yield at 3% to 5% reduction in overall fuel consumption.
So now I'm going to talk about ethical value-based consideration, which is, in my opinion, engineers have a responsibility to minimize environmental damage. Secondly, reduce greenhouse gas emissions, promote sustainable industrial practice. practices, which will cause the benefits and challenges too. In benefits, first thing first, lower energy costs in the long term and improve company reputation, while the challenges is high initial installation costs and additional maintenance expenses. For now, I'm going to talk about professional ethics of engineer, which is prioritize public safety and welfare, consider environmental impacts in decision making, and follow sustainable engineering principle, balance economic and environmental consideration and responsibility. The impact for the workers are better workplace efficiency, reduce exposure to excessive heat, while for the society, clear air quality and reduce environment air pollutions. And also for the future generation, conservation of energy resource and more sustainable industrial development.
In conclusion, this case study demonstrates how fundamental thermodynamic principle can be applied to optimize a natural gas-fired industrial boiler. By analyzing the system energy balance, flue gas emissions were identified as the primary source of waste. Installing an exhaust economizer effectively captured this energy to preheat incoming and feed water, driving down resource consumption and operating expense. Ultimately, implementing this upgrade balanced business profitability with an engineer ethical duty to build a sustainability future.